This question tests your understanding of principal component analysis, PCA, a technique I use to reduce the number of variables in a dataset while retaining most of the important information. I'm focusing on how to interpret the results of PCA using the explained variance ratio. I'm dealing with a dataset that initially has 100 different characteristics or features for each data point. I want to simplify my dataset by reducing the number of features from 100 down to just 10 using PCA. These 10 features are called principal components, and they're carefully chosen to capture as much of the original variation in the data as possible. I'm using the PCA function from the Sklearn library in Python, a very popular tool for data analysis and machine learning. This instruction means I need to choose every statement that is a true description of how the explained variance ratio works in PCA. I explain the proportion of the total variance in the original dataset that each principal component accounts for. Think of it like this: you have a big pile of data, and PCA helps you find the most important parts. The explained variance ratio tells you how much each of those important parts contributes to understanding the whole pile. It's a key metric in understanding how well your PCA is doing. This question tests your understanding of how PCA's explained variance ratio works. We're starting with 100 different things describing our data and reducing them to just 10, which represent the most important patterns in the data. This is our starting point, a dataset with 100 different features, variables, for each data point. Imagine each feature as a different aspect of something we're studying. For example, if we're looking at houses, features could be size, location, number of bedrooms, etc. This is the process of using PCA to reduce the dimensionality of the dataset. We're using PCA to translate the original 100 features into 10 principal components, which capture the most important variations in the data. After the PCA transformation, I now have a new dataset with only 10 features, representing the most important information from the original 100 features. This reduction simplifies my data without losing too much crucial information. I understand PCA, principal component analysis, explained variance ratio as a measure showing how much each principal component contributes to explaining the total variation in your original data. It's like splitting a pie. Each slice represents a principal component, and the size of the slice shows the amount of variation that component accounts for. Pretty cool, huh? This question is a test on understanding the interpretation of PCA's output, specifically, the explained variance ratio. We start with many characteristics, 100 features, and use PCA to shrink it down to a smaller, more manageable number of characteristics that represent the most important information, 10 components. This statement is always true. Think of the explained variance ratios as percentages. If you add up all the percentages of variation explained by each principal component, they will always total 100%, or 1.0 in decimal form. That's because these components together explain all the variance in the original data. This is also true. PCA cleverly orders the principal components, starting with the one that explains the most variation. The first component grabs the biggest piece of the pie, followed by the second, and so on. It's like greedily taking the largest slices first. This is the core definition. The ratio directly shows what proportion of the total initial variability each principal component can account for. Each component's variance ratio is its slice of the pie compared to the whole pie. This means we've successfully reduced our dimensionality while retaining most of the original data's important information. 0.95, or 95%, of the variation from the original data is kept in the reduced 10-dimensional space using the first 10 principal components. It's a great result. I'll explain what the explained variance ratio is in principal component analysis, PCA. Imagine you have a bunch of data points scattered around. PCA finds the best directions, principal components, to capture the spread of this data. The explained variance ratio for a principal component tells you what percentage of the total spread is explained by that particular direction. It's like figuring out which directions capture the most important aspects of the data's variability. This question tests your understanding of PCA's explained variance ratio. It presents a scenario where you're using PCA to reduce the number of features in your data from 100 to 10. Then, it asks you to identify true statements about the properties of the explained variance ratio after fitting PCA. It's all about interpreting what those ratios mean. This statement is true. Think of it like this. The explained variance ratios represent fractions of the total variance, and the sum of all fractions should always add up to 1 or 100%. This is also true. PCA is designed so that each subsequent component captures less and less variance than the one before it. The first component always explains the largest fraction of the total variance, and it goes down from there. This is simply the definition of what the explained variance ratio is. Each principal component gets assigned a ratio that indicates the amount of variance in the original data it accounts for. That's correct. If 95% of the total variance is captured in the first 10 components, it means that the remaining 5% is less important and can be safely discarded without significant loss of information. You've captured almost all the important data structure in your 10-dimensional representation. I'll explain what the explained variance ratio in principal component analysis, PCA, means. Imagine you have a bunch of data points scattered around in a high-dimensional space. PCA helps you find the best directions, principal components, to represent this data while keeping as much of the important information as possible. The explained variance ratio for each principal component tells you what percentage of the total spread, variance, of the original data is captured by that specific direction. For example, if the first principal component has an explained variance ratio of 0.7, that means that direction captures 70% of the total variance in your data. Pretty cool, huh? This is the setup for the question. We're starting with 100 different characteristics, features, and we're using PCA to simplify our data by finding the 10 most important directions, principal components. We're then examining how much of the original data's spread these 10 directions can explain. This statement says that if you add up the explained variance ratios of all 10 principal components, the total will equal 1 or 100%. This is always true. PCA ensures that all the variance is accounted for by the components. Think of it like slicing a pie. You must always have 100% of your pie in the end, whether you slice it into many pieces or few. This means the first principal component, the direction that best represents the data, will always capture at least as much variance as the second one. It's like finding the best line of fit through your data first and then the next best one. The first one is always at least as good at describing the spread of the data as the next one. This is a direct definition of what the explained variance ratio is. It's simply the fraction of the total variance in the original data explained by each principal component. It's a simple, yet powerful way to measure how well each component summarizes our data. This statement explains how we interpret the explained variance ratio. If the first 10 principal components explain 95% of the variance, it means we've captured almost all of the important information from the original data using just 10 dimensions instead of 100. We've successfully reduced the dimensionality without much loss of information. That's a win. This question tests your understanding of principal component analysis, PCA, a common technique for reducing the number of variables in a dataset while retaining as much information as possible. We'll be focusing on how PCA explains the variance in your data. I'll explain this. Think of the total variance in your data as a pie. PCA slices this pie into pieces, each representing a principal component. Each slice's size shows how much of the total variance that component explains. Because we're accounting for all the variance, adding up the sizes of all the slices, explained variance ratios, will always equal the whole pie, 1.0. PCA is greedy. It finds the direction, principal component, that captures the most variance first. The next component captures the next most asterisk, and so on. Therefore, the first component will always have the highest or equal explained variance ratio. Yep, that's exactly right. The explained variance ratio for a principal component simply tells you what percentage of the total variance in the original dataset that component accounts for. It's a straightforward measure of how much each component contributes to explaining your data. This statement means if you use only the first 10 principal components, you retain 95% of the information in your original dataset. This is great for dimensionality reduction because it lets you reduce the number of variables without losing too much information. The problem starts with a dataset having 100 features, which is then reduced to 10 principal components using PCA. This shows how PCA helps in dimensionality reduction, simplifying complex data by focusing on most important aspects. This is the core concept we're grappling with. A measure of how well each principal component captures the spread of your data. Understanding this ratio is key to understanding what PCA is doing.